Let's take a closer look at the kinds of things that can be achieved when we are using SQL injection. In the previous video, we've looked at how injecting a quote followed by some short SQL statements can change the meaning of a query. And it allowed us to do two things. One is conduct an authentication bypass, and secondly was to dump the entire contents of a database. It's a little bit more subtle than that, and let's look at that in this video. So we're going back to SQL injection, and in this particular case, remind you again, our adversary on the left will inject some form of data into an HTML form or another input field and pass that into the web server. The web server passes this through to the application server where it might get interpreted or where it might be used to influence the SQL query that is being sent to the backend database. Of course, the results of that backend database query are then being sent out to the user, the adversary. What we were doing before was extending a current query with either simple quote 0 quote or 1 equals 1, which would dump out the contents of a entire table, but it was the same table that the developer was interested in. We can also terminate a query altogether. In this example here, we would do a quote semicolon, which ends the first query. Most likely it also doesn't return any values. But I can just add a second query to the end. As of course, that does require me to know what the table looks like. For example, if we are dealing with a users table, it is likely that there will be fields called username and password, or maybe login and password. It might take a few guesses, but eventually, with some reasoning and some thinking about how a developer works, you might be able to get in there. So in this particular case, we extended our query, quote semicolon, by adding a new user to our database, a username and password with hacker and gotcha. And at that point, we don't need to use SQL injection anymore to bypass an authentication system. We can use the authentication system to successfully authenticate with a username and password, as shown here. Again, it does require that a hacker knows what the database schema looks like, or at least that he's able to guess what it might look like. In open source software, not a big deal at all. You just look up the source code and you have your database schema right there. And in other widely deployed software, it's often commonly known what the schemas look like also. So this is not the hardest hurdle. So this is another use of SQL injection, in addition to doing a full-on authentication bypass if the developer was sloppy by only looking for the return count of fields, or by extending again, a query that already existed. Now we are able to add a second query and maybe even a third query to our database. And that could insert, like we do here. But of course, depending on the permissions on the database, that second query or this third query or whatever we're adding to this might also be able to change values in the database, delete values from the database, or maybe even drop entire databases altogether. So all in all, this is a very dangerous form of attack. Other interesting things to note are that in a relational database, which is often self-describing, the database schema itself is stored in the database as well. If you're able to figure out what the backend database is, and sometimes you're able to do that pretty easily by looking at error messages or just by looking at product spec, you know what those tables look like. For example, in a PostgreSQL database, all the tables are stored in a schema, in a table called information schema.tables. So even if you don't know what a database looks like, as soon as you're able to do this kind of extensions of the queries, you can start retrieving information about the database and then use that information to query it. And then for each table, you can find additional information such as, what columns are in this table, what data types do those columns have, all kinds of interesting information that can help you really get a grip of the database that you're trying to analyze. SQL has an operator for this even. It's built into the database management system, where you can take the results of one query and glue to that query the results of a second one. That's called a union operator. It takes two result sets and unions them together. And so we could do something along the lines of, quote, union select table name from information schema.tables, where tables schema equals public. And that might actually allow us to map out the entire structure of the database. And even database tables that you might not have direct access to either through the user interface that you are using, or maybe even tables that were never meant for you to be accessing are now accessible using this technology. So it does allow you to really map out all the tables and all the contents of all the tables in the database. And you can imagine that that's a pretty dangerous capability to have if an adversary can do that. Fortunately, there's a little bit of a limitation, and that is that both of the queries that are glued together using that union statement have to be union compatible. Union compatibility is something that we discussed in CSC 263 database management systems. And it means that two tables have to have the exact same number of attributes returned, or two queries have to have the attributes returned. And they must be type compatible. And that means that if the first column in the first table is an integer, then the first column in the second table also needs to be an integer. So when we're dealing with these union select queries, like we see here, in this case I'm only selecting one attribute from the table. That means that the query that we are extending can also only return one attribute. In this case, that is indeed true. Select role from users, so it's only returning a role. So that would work. But if we go to a query that does a select all, select star, we have to figure out what that number of columns is and what types they are. Now, there is one thing that makes our life easier, and that is that the null data type in a database management system matches with all attribute types. Null in a database means I don't know or I don't care, but it's not the same thing as an empty string or the value 0. But that allows us, combining these two things, could allow us to map out a complete database management system and then use it to inject our queries. So between being able to extend a query with adding additional result sets, by able to chain queries so that we can execute multiple queries where there was only one intended, or where we can extend a query by adding fields across different tables to which we might not even otherwise have had access. We can do a lot of damage to a database backend if we use SQL injection. The root cause of SQL injection is a lack of input validation. The fact that we are taking user input and passing it through verbatim to a backend system which then executes it. In the next video, we'll explore how we can prevent that from happening. But for now, between the 4 SQL injection attacks that we have seen, again, using it for authentication bypass, or using it to enumerate the contents of a single table, using it to chain queries, and using it to merge multiple tables into one result set, we have a lot of opportunities to do damage with SQL injection. Let's go take a look at what it looks like in practice to do something like this. Back to our zip code database, where we did some other SQL injections as well. On the right-hand side, you'll see the query that I'm looking to execute. I'm trying to answer the question, what tables can I access through my database schema? So that would be select table name from information schema.tables, where table schema equals public. It is assumed that this is a Postgres database. I happen to know that, but if it weren't, a few trial and errors would show this. Now, as always, we'll need to terminate the previous query, and that shows us then that we now have select all from zip, where zip code equals quote, quote, quote. That gives us an error message, so we'll do this one. And no more error messages. That means that whatever we're going to be doing has to happen between this quote and this double dash. So our injection code goes there. Now the problem is we don't know how many fields there are here, because we have a select star. I think it's fair to assume that if we look at zip, on, off, pop, let, long, and type, that having 1, 2, 3, 4, 5, 6 fields at minimum is a reasonable expectation. So we'll start with adding 5 nulls here to get to that union compatibility, which we require to have the same number of fields returning from this query as from the query that we're adding. We're also going to add the union statement here to turn it into a union select. Of course, the terminator, so that that is this terminator over here. And our double dash at the end is already there. So copy paste. Let's see what happens when we do this. Error message. Now we don't see the Postgres error messages, we just see the PHP messages. But it's fair to assume that if we take a look at this query here, and let's just select the whole thing and paste it under here. Oh, under here. Syntax highlighting for SQL is enabled. There's no odd things. So syntactically, at least, the query is correct. That means that what we're doing now is just a matter of figuring out how many fields we need. And we can increment them just one by one. So copy paste. Let's go back to our input field and see where we're at. And there we go. It turns out that my original query, select all from zip, returns 1, 2, 3, 4, 5, 6, 7 columns, sorry. And fortunately, table name, which is a string, is compatible with cities here, which is also a string. So now we have union compatibility. And the output we're getting here is actually select all, or actually select table name from information schema.tables. So even though I knew there was a zip table in this database, I now know that there is a cities, an acceptable cities, and a zip area table as well. I've just learned more about the contents of my relational database by using a union select. And I could continue doing this by now starting to select values from cities and from zip. Not from zip we already have, so from cities and from acceptable cities, from zip area, after I map them out using exactly this same mechanism. This gives you full and unlimited access to the database schema, depending on how access controls are configured. All in all, an interesting technique if it is present and available to you.